This probably looks like some really advanced electronics. It looks confusing. I mean, look at it. There's wires everywhere. I'm controlling 2 servo motors through a radio signal. Like this one could be an x-axis, this one could be a y-axis. Maybe I rotate a camera mount that goes left, right, and up and down, or maybe this could be the ailerons on an airplane, and then this could be the rudder on the tail. But after you watch me put this together, I think you're going to agree that it's actually pretty easy. This is actually beginner electronics, and I think this is where you should start. The wires are like Legos. There's like 28 wires here. You just put this middle wire on D5, this middle wire on D6. Now put this left wire on 3V, and put this left wire on 3V. That's all it is for 28 wires. And the code, who said you had to write your own code? You should just copy it and paste it from someone like me who's already put it up online, and then you can put it on there and off you go. I started learning about electronics a year ago when I was 39, and this is where I wanted to get. I wanted to start with radio because it's the future. It's the foundation of all modern communication and location. The boats, the trains, airplanes, they're all using radio technology. The vehicles that are orbiting the Earth right now, they're using radio. The rover that's on Mars. And this is exciting. It's not that hard. The code is about that much code. If you're going to learn about LEDs and temperature sensors, humidity, motion sensors, you might as well start with this and then just add it to it. If you're going to move things and detect things, you might as well do it through a wall, upstairs, downstairs, in a building across the street, in a car down in the parking lot. It's pretty rad stuff, and this is where you should start. All the parts are about $50, $10 for these, $10 for that, $10 for that. But I think you'll see here, if you're 40 years old like me and you have no electronics experience, you can do this. It's Legos and then copy and paste. If you have a kid that you want to get them introduced into electronics, start here with cool stuff going through walls. And if they play video games and if they can copy and paste in a Word document, then they can figure this out as well. Get your radio antenna and plug it into the module. And notice how my wires are gray, purple, blue, green, yellow. You can make those wires any color you want. I try to keep them the same colors for the same pin so it's easy for me to remember. CE is a gray wire, CSN is a purple, SCN is a blue, MO is a green, M1 is a yellow. And the last pin, leave it empty. I made black for negative and white for positive. Exact same colors, same wires for the second radio antenna. Now I don't have to remember so much, I can just think about colors. I can think that on the left one is a gray, then a purple, then a blue, then a green, then a yellow. It's easier for me to remember. I'm more of a visual person. Remember to leave the last pin empty. Let's make black negative and white positive. You can make those any color you want, but to me black is negative, dark, white is positive, bright. Let's put these two little breadboards together. I did blue and white, green and yellow. I chose blue and white in my mind to be like the left side, the transceiver side. Use a napkin here. These pins hurt. You don't want to put too much force on any one part of these boards because you could break them. So I'm trying to dissipate the force. I try to put the second nano in exactly the same position as the first nano. The same amount of positions over from the right, the same amount of positions over from the left. That's why every position is about the same, every wire is about the same. This just makes it easier on my mind. I don't have to think about so much. Notice how they look almost exactly the same in the same position. It makes it easier to spot a problem. Okay, I'm putting the gray one into D9, the purple one into D10, the green one into D11, and the yellow one into D12. That one blue one, that's going to go into D13. Let's give the radio antenna some power. Black wire is negative. White wire goes to 5 volt, 5V. Black wire goes to GND, which means ground, and the white wire goes to 5V, which means 5 volt. These radio antenna need at least 5 volt. Actually, that module will step it down to 3.3 volt, but we don't need to worry about that. We got the module, it'll take care of that. Now try to set up your wires so that everything sets nice and flat. That's what I'm doing here. I'm trying to figure out which wires go inside of which wires so that everything sits nice and flat on the table. And easy for me because the colors are all the same. On the second nano, everything's in exactly the same spot. Gray goes to D9, purple to D10, green to D11, yellow to D12. Put the blue one into D13. Put the negative into GND ground, and put the white one, the positive, into 5V, 5 volt. Try to get this to set flat on the table. Notice how I try to get everything to look exactly the same. It makes finding problems a lot easier. If a blue wire is where a yellow wire is supposed to be, then it's easy to spot. If a gray wire is where a blue wire is supposed to be, it's easy to spot if everything looks the same. I know blue is going to be my left nano and the green one is going to be my right nano. I'm going to put these potentiometers like way at the very end. That gives me some more space to work with. The middle pin on those potentiometers is the one that sends a signal. First, let me set up the yellow pin. I chose yellow to represent a signal, and I'm going to plug that into A1 and A0. The signal is going to come into A1 and A0. Now I'm going to run some power through these potentiometers. I use red to represent positive. Going to go on one side of the potentiometer and plug that into the 3V3. That means 3 volt. Exactly the same on the other one. Let's use blue. That's kind of dark and negative to represent ground. That's going to go to G and D, ground. This makes it nice and easy. Every potentiometer should have a red, yellow, blue. Red, yellow, blue. Red is positive, the left pin. Yellow is the middle pin, the signal. And blue is the right pin, which is the ground. They can actually be interchangeable. The red and blue pins can actually switch back and forth. It doesn't matter so much. Okay, now let's get the servo set up. You know what? Everything's bunched together, so I'm going to use this red wire to bring the power off into the side. I'm going to get some of this 5 volt here over to the green breadboard and get it out of the way, and the blue to bring the ground over out of the way. See 5 volt, I'm bringing it over there. G and D ground, I'm bringing it over there. But I'm going to try to keep things organized. That's one red wire for one servo's positive, another red wire for another servo's positive. A blue wire for one servo's ground, a blue wire for another servo's ground. So this looks nice. It's red, 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 blue, blue, blue. Everything's nice and organized. It's easy to spot any mistakes. I should not see red, blue, red, blue, red, blue. I should see red, 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 green, green, green. Let's plug in some white wires to send the signal to the servos. I chose D5 and D6. You can choose any color you want. I chose white because it's nice and bright. I should have 2 white wires for signals, 2 red wires for positive, and 2 blue wires for negative to each servo motor. You see on these servos, they have brown to be the negative, but I chose blue. Blue to brown. I chose red for positive. The servo has red for positive. That makes it a little bit easier. They have yellow for signal. I chose white for signal. With the next servo, I'm going to try to have everything exactly the same. Blue negative to brown. Red to red. Positive to positive. White to yellow. Signal to signal. White, red, blue. Everything is organized. It makes it easy to see any mistakes. Let's plug these nanos in, get some power. Plug them into the serial ports of my laptop. Okay, there's power coming onto the left one, to the right one. Okay, let's download the software called Arduino IDE. That's a program that's going to convert our code and put it onto our Nano. This is free software. Let's install Arduino. In the description under my video, you can download the code. This one I called TX Blue. I call it TX because it's like sending the signal. It's got the potentiometers. I called it blue because it's got the blue breadboard. I called this one RX because it's like receiving the signal. It has the servo motors and it has a green breadboard. You can call your code whatever you want. Left, right, top, bottom, color, name. It's just to help me remember what I'm doing here. Let me open up the code. This one's going to go on the left. TX blue, RX greens for the right one. put TX on the left and RX on the right. Now I noticed something, but maybe you don't notice it. You see down here where it says radio on the left and it's blacked out, and over here on the right it says radio and it's blacked out. What that means is the Arduino software doesn't understand what I'm talking about when I say radio. If you're going to talk about cooking, you need to know the words of cooking, the vocabulary of cooking. If you're going to talk about gardening, you need to know the words of gardening and the vocabulary of gardening, or else we won't understand what we're talking about. The same applies with this software and radio technology. It doesn't know what I'm talking about when I talk about radios. So I need to give it the vocabulary, the language of the radios. Go up to Manage Libraries. Look for RF24. Install this one, TMRH20 and Avamander. And you'll notice after I installed it, now this is orange. So now the Arduino software understands what I'm talking about. So I can talk about radios all day long, and it's like, oh, I know what you want me to do. You want me to open the writing pipe. You want me to set the PA level. You want me to stop listening. So now it's ready to work with the words that I'm using. We're just about ready to upload the code. Go under Tools. Make sure the board is set to the board you have. There's tons of different boards, but today I'm using a Nano. Make sure this one is set to Nano. Make sure the one on the right, the one that I'm calling green, is set to Nano. And processor, I know that the one I have is using the old bootloader. That'll make sense here in a minute. You might not know which one you have until you buy the Nanos. Some of them are going to be the old bootloader, some of them might be this one, some of them might be that one. I have the old bootloader ones. The blue, the transfer, the Nano with the potentiometers on my computer is set up to COM number 6. The receiving one, the one with the green breadboards, is plugged into my COM number 7 on my computer. Now look what happens if I try to upload the code with 328p. It's kind of hanging. There's something wrong. It's not taking the code. So let me try ATmega 168. Try to upload that. Now there's an error. It's not working. Well, let me try old bootloader. Okay, I'll see the lights flashing on my Nano board. That means it's taken the code. Okay, it went up. So, okay, there you go. So I know that I had the old bootloader. Let me go to the right. Let me double check one more time. Nano, old bootloader, COM number 7. Okay, go ahead and upload that code. I'll see the lights flash. When they're done flashing on that right Nano, the green one, I'll know it's been uploaded. Well, look at that. You're controlling 2 servo motors across a radio signal. You can have 2 servos remotely attached to a battery. You could have everything remote attached to one battery. You could attach your servos to something like an Xbox that has 5 volts output. You could plug your servos into the wall. Okay, that does it for radio. Now you can go off and do more complex things if you want, or you can back up and do a little bit more simple things. But I put you a year in. It took me a year to get here. And I just wanted to show you that with 28 wires and a little bit of code that you can copy and paste, you can start with radio. Now if you want to add LEDs to this, you want to add temperature sensors, you can do that. Actually, these are not the parts that I bought when I first got into electronics. The only original parts that are from my first original kit are the servo motor and some of these wires. The first kit that I bought was this one, and this kit comes with LEDs, with resistors, with motion sensors, temperature, humidity sensors, LCD screens so you can write messages. And then I'm going through all these parts, I'm learning how to use each one of these components, and I'm like, well, when are we getting to the radio part? And I found out, well, this was for beginners. And so I started to add and purchase some of my own new parts. I just wanted to get you here, get you where I wish someone would have shown me so that I could have started off with radio. I intentionally didn't talk about what the parts mean. That's going to be in another video. I didn't explain why do we use these things, breadboards, does the color matter? No, it doesn't. I didn't explain things like these wires, why do we have these different colors and does that matter? No, it doesn't. And I didn't explain style things, like why do I like to use these USB extenders to give myself a little bit more room. I'll explain that stuff in a different video where I explain the flow, the process that I use when I do this hobby. I'm going to end this video talking about the COM ports. Now, COM ports might be confusing for some people. It's basically telling your computer that send this code to COM6 and send this code to COM7. So you got to get your COMs lined up. I knew that with my computer this is COM6, that's going to go to this nano, and COM7 is going to go to that nano. If you're sending some code out of here but it's going to that one, or you're sending some code out of here and it's going to that one, your stuff's going to get messed up. Your code's going to the wrong place. If you're sending it to COM number 10 off somewhere else, then you're not going to get your code where you want it to go. So let me wrap up explaining how the COM ports work in your computer. When we upload our code, we need to know which ports things are plugged into, the left nano and the right nano. I'm in Device Manager on my Windows laptop. Let me plug in that blue and white one, the left nano, into here, and let's see what happens. It shows that that's COM9, okay. So I know 9 is on the left. I plug in the green and yellow nano on the right, okay. It's calling that COM10, good to know. Well, actually I have this new thing called a Thunderbolt, and so I plug it in, same process, and I find out that the left one, the blue and white one, is COM6, and the right one is COM7. Your computer might be different. You might have to do this plugging in and plugging out stuff and figure out which COM ports connect to what. I got 6 and 7. This is all the equipment that you're going to need, about $50 worth. For the radio, we're going to use 2 NRF24L01s. You can actually use them with the antenna off. Do buy them with the module. Sometimes you can buy them just like that, but then I see people, they have to do some soldering and connecting wires to make things work. So complicated. If you get this module, you just plug it in like that, the module plugs into your nano, and you're good to go. You don't have to worry about adding wires and soldering those antennas. I have some nice potentiometers here. I like this kind. I have 4 little breadboards because I knew I was going to be working with radio, small nanos, and trying to get the radio into small spaces. So I have these little breadboards to help me hold everything together. With the nanos, same thing goes with soldering. Sometimes you can buy them with these pins off. Don't do that. Just buy them like this with the pins already connected. They come with these cords to connect to your computer and for power. I'm going to say something that I may confuse you with. It's not that bad. It'll make more sense when we're working on the computer, but I found out after I bought these that they were what's called the old bootloader. If you buy these nanos, you might have the old bootloader or the opposite, which is the not old bootloader. That'll make more sense when we talk about software. For wires, 14 male to male. Again, color doesn't matter. That's just for keeping yourself organized and knowing what wires are going where. 14 of them. Attaching to this module, get 14 female to male wires. Again, the colors don't matter. You notice that I made them match in colors. That just makes my life easier. Things are more organized and make more sense in my mind. And then for the servos, we have 2 SG90 servo motors.